Okay, so we'll do some stability chart problems. Okay, a vertical cut is made in a clay deposit. Okay, find the maximum height of the cut which can be temporarily supported. Okay, so ഇവിടെ C തന്നിട്ടുണ്ട്. C is equal to 30 kilonewton per meter square, phi is given 0, gamma is given 16 kilonewton per meter cube. Okay, so as it is a vertical cut, we have I is equal to 90 degree. Okay, so from the stability chart, okay, I equal to 90 and phi is equal to 0. What is the value? It is 0.261. Right, you got the value Sn as 0.261. So taking Fc equal to 1, okay, 0.261 is equal to 30 divided by 1 into 16 into h. Okay, you get height of vertical cut. Right. Okay, next is also similarly simple problem. Okay, determine the factor of safety with respect to cohesion if an embankment 25-meter high and having a slope of 40 degree is subjected to a sudden drawdown. Okay, so we have to find the factor of safety. Okay, sudden drawdown, it is mentioned here. We have C is given, phi is given, gamma sat is given. So we know in the theoretical portion, yeah, it is mentioned here. For sudden drawdown, okay, yeah, here it is given. For sudden drawdown case, we have tan phi is equal to gamma dash divided by gamma sat multiplied by 1 by f phi tan phi dash. Okay, so we substitute here. So taking f phi as 1, tan phi w is equal to 18. What is given? 18 gamma sat is given. Okay, we have to minus it by 9.81. Okay, multiplied by tan phi. Okay, phi is given 10 degree. You get phi w as 4.59. So correspondingly, you need to check for 4.59 and what is the stability chart number. So I think the correct value in so you have to do it by interpolation. Okay, make sure that you know how to do interpolation. I think I have taught you for the third module, I think so. Okay, so you substitute it. Okay, Sn is equal to C divided by Fc gamma h. Okay, Fc gamma sat it is. Okay, you get Fc as 0.684. So which is less than 1. Okay, so the slope is not safe. When slope is less than 1, it is not safe. Okay, it is there in the theoretical portion. You have to study it and then try to solve the problem. Okay. Okay, next is also a very simple problem. Okay. Okay, this one. Determine the factor of safety with respect to shear strength of a slope 10-meter height and having an inclination of 40 degree of the soil with C is equal to 30 kilonewton per meter square. Phi is equal to 10 and gamma is equal to 19 kilonewton per meter cube. Okay. Here we have height is equal to 10 meter, I is equal to 40, C is equal to 30 kilonewton meter square, phi is equal to 10 degree. Okay. Here, F factor of safety is obtained by trial and error method. Okay, let us assume, okay, f phi is equal to 1. Okay, we know from theoretical portion f phi is equal to tan phi by tan phi. So we take this side tan phi m, which is tan phi m is equal to tan phi by f phi. Okay, tan phi is 10, right? Tan 10 degree divided by 1. So phi m you get as 10 degree from the chart. Okay, stability chart, you take f phi m is equal to 10 degree and I is equal to 40 degree. Phi m. Phi m is equal to 10 degree, then it is 40 degree, right? I. So as I is not given here, what do? You solve it from the interpolation, right? You get the value Sn. It is 0.097. Then you substitute the stability chart number formula. C Sn is equal to C divided by Fc into gamma into H. So Fc, you get a value of 1.63. For F51, you have Fc 1.63. Similarly, you assume Fi as 1.2. Okay, same method. Okay, Fi is equal to tan phi divided by tan phi m. Okay, you substitute tan 10 divided by Fi is changed to 1.2. Okay, correspondingly phi m you get. Then again you find that stability chart number. Okay, for 1.3. Okay, you do it for 1, 3 or 4. so as to draw a chart. ഇത് ചെയ്യുന്നത് ഒരു ഗ്രാഫ് വരയ്ക്കാൻ വേണ്ടിയിട്ടാണ്, ഫാക്ടർ ഓഫ് സേഫ്റ്റി കണ്ടുപിടിക്കാൻ വേണ്ടി. ഓക്കെ, സോ യു ഹാവ് ഡൺ ഇറ്റ് ഫോർ 5.1.3 and then F5 for 1.4 corresponding F these, you get it. Okay, so you draw a chart. Okay, you you plot a graph. Okay, sorry, you plot a graph for F5 this axis and FC this axis. Okay, you get a slope of like this. 4 points are noted down here. Okay, for FC equal to F5, you take a line drawn at 45-degree cuts. Okay, you take a line here, keep the protractor here, make a 45-degree cut here. At what point it intercepts, that is your Fs. Okay, at what point it intercepts, take it as 1.34. Right, Fc equal to Fi. If E axis you get the same value. Right, so Fc is equal to Fi, which is equal to Fs. Okay, that you do for that is how you do trial and error method. Okay, try to solve maximum problems. Okay, for geotechnical engineering, most of the questions are not theory based. It will be mostly problems. Okay, try to do maximum problems. Okay, that's it.